Continuing section 6.5, we're now going to look at some applications of solving equations by factoring. So looking at our example here, our first two, we have some geometry concepts. First example, we have the longer sides of a parallelogram are 8 feet longer than the distance between them. If the area is 48 square feet, find the length of the longer sides and the distance between them. Well, I guess what would help to start this off would be to kind of draw a picture to understand really what we're considering here. Parallelogram is a figure that just has two pairs of parallel sides. Could be a square, could be a rectangle, or could have slanted sides like this. Only requirement is that this pair of sides are parallel, so are the top and bottom. So what we know is we have, I guess we could call this the height of the parallelogram. And what this problem is saying is that the longer sides of the parallelogram, that would be like the top and the bottom, they're 8 feet longer than the distance between the sides. So the distance between the two sides that are longer is the height of the parallelogram. These actual top and bottom sides are 8 feet longer than that height. So if we're calling that h, we could call this distance across the top, which is the same as the distance across the base. We could call that h plus 8 extra feet. So what other piece of information they give us, okay, we just kind of used this, 8 feet longer. But the other piece of information we can use is that the area is 48 square feet. So it tells us we're going to have to use the area formula. So in case you don't know this, the area formula for any parallelogram is multiplying the base times the height. Okay. So looking at this formula and filling in what we know the area is going to be 48 square feet. We're told that in the problem. The base is this length right here, which is actually going to be equivalent to that top length. So h plus 8 is what we're calling that. And then the height of the parallelogram, well, that's what we're calling h. So what we can do is start to clean up this expression, or this equation, by distributing the h into this parenthesis that it's attached to, multiplying it to both terms will give us the equation 48 equals h squared plus 8h. Okay. So we almost have this in a form that's factorable, except using the whole idea of the zero product property, we want to get this equation set equal to 0 first, and then see if what's left here on the right hand side is going to be factorable. And in all these problems it should be. So we'd want to subtract 48 from that side, which is going to make it become a minus 48 on the right hand side. So we end up now getting a 0 on the left hand side, and on the right hand side have h squared plus 8h minus 48. So we want to look at this expression, now that we have it set equal to 0, and try to factor it. We want to try to turn it into a parenthesis times another parenthesis, and then we can apply that zero product property. Okay. So this is in a form where there is no coefficient, there's no number in front of the h squared, which is good. That means this is one of the easier ones to factor. We need the two numbers that add to give us 8, but also have to multiply to give us negative 48. Okay. These two numbers are going to be a positive 12 and a negative 4. Those will add to give us 8. But if we multiply 12 times negative 4, it will give us negative 48. Okay. So 12 and negative 4 are the numbers we wanted. That tells us how this will factor. Our equation would then become 0 equals h minus 4 and h plus 12, since it was a positive 12 and a negative 4. And well, from that, we can find out what our two h values would be that would make this equal 0. A positive 4 would make this parenthesis equal 0. And a negative 12, if we plugged in for h, would make that parenthesis 0. So those would be our two solutions in this problem. H either equals 4, and what are we finding here? H was the height, and we're dealing in feet in our original problem. So our height could either be 4 feet, or the value of h that will make that a 0, the height could be negative 12 feet. Okay, well that doesn't really make sense. How could you have a negative height? In these real world situations, since we're dealing with a quadratic situation, something with an h squared, we're going to often have these two solutions. One won't make sense oftentimes. So we want to go ahead and take this negative solution and just go ahead and ignore this one because it doesn't even make sense in context to our problem. So our actual solution in this case is going to be the height is 4 feet. Okay? So we found the distance between the two sides, the height is 4 feet, but it also wanted to know how long was that the sides across the top and bottom. So how long were the longer sides? So to find those, well, we know it's going to be that formula h plus 8. Our height plus 8. We just found that our height was going to be 4 feet. So 4 plus 8, we know that it's going to be the long sides across the top and bottom are both going to be 12 feet. Okay. So our height is 4 feet, longer sides, distance across is 12 feet, and you see that 12 feet is going to be the opposite sign of the value we ignored. That often will be the case. Actually might always be the case. I'm trying to think of an example when it wouldn't be. But so you can keep that in mind. But you do want to plug the value that did make sense back into, you know, the equation up here to find what the other side, the longer sides, would be. So our parallelogram is 12 feet across the top and bottom, and it's 4 feet tall. Okay. The next example, I actually want to skip the one on the bottom of the page and look at this example I have here on the back, dealing with a rocket. Okay, we have that a rocket's height after t seconds is modeled by the equation h of t equals negative 16t squared. Actually, this is supposed to be a positive, so ignore that. Minus 64t. Okay, that's supposed to be positive as well. Sorry. So 16t squared plus 64t is our equation. At what time or times is the rocket 192 feet high? Okay, at what time or times is it that high in the air? So we need to take the equation they give us and I guess use it in order to find this value. Okay, at what time, what second is it going to be that high? So we'll do that. Put this here. Okay, so first things first. Since h of t, this function tells us the height, if we want to see when it's 192 feet, we can replace the h in this equation, the h of t, with 192. Okay, because putting in some number for t and evaluating is going to tell us how high the rocket is at that time. So we take 192 and replace h of t with that. So 192 equals 16t squared plus 64t. Okay. So now we have ourselves an equation. The only way we really have learned so far how to solve these is get them set equal to 0 and try to factor. So we would want to subtract 192 from both sides of the equation, making it a minus 192 on the right hand side, because it would cancel out there, giving us the 0 we want. So we get the equation 0 equals 64t, or 16t squared, plus 64t minus 192. So we want to factor this. This unfortunately has a number in front of the t squared, which makes it one of those more difficult problems to factor. However, 16 happens to be a number that will divide 16, 64, and 192. You always want to check for GCF first in order to see if it'll help make your problem a little easier. And we do have a GCF, it's 16. So if we pulled out a factor of 16, that'd leave us with a t squared. 16 times 4t is going to give us 64t. And then 16 times a minus 12 is going to give us minus 192. Okay, so that makes it a little bit easier because now what's inside this parenthesis we can factor a little bit easier since there's no number in front of the t squared. So this is where we need two numbers that add to give us 4 and multiply to give us negative 12. Okay. These two numbers are going to be positive 6 plus a negative 2 will add to give us 4. Positive 6 times a negative 2 will give us negative 12. Okay. So that's the only combination that will do that for us. So we know our equation now will factor into the form 0 equals the 16 out front, but we can now fill in two new parentheses factors of t plus 6 since it was a positive 6 and t minus 2 since it was a negative 2. Okay, if we multiplied, FOILed these two out, it would get us back to the t squared plus 4t minus 12. Alright, so now we want to go ahead and finish this problem by finding our two solutions. Remember, because the 16 GCF out front doesn't have a t attached to it, we don't need to worry about that. We just need to worry about where there's variables. So this t plus 6 factor and this t minus 2 factor, we want to find what are the two values that would make those equal 0. So either t plus 6 equals 0 or t minus 2 equals 0. This you maybe could just do in your head. Okay, well, a negative 6 here when we subtract 6 from both sides, t equals negative 6, or adding 2 to both sides, t equals 2. So there's our two solutions, but what did we actually find? Well, the question asked us, at what time is the rocket 192 feet high? And we're dealing in seconds. So do these answers make sense? Well, one does. After 2 seconds, that rocket's going to be 192 feet in the air. Also at negative 6 seconds. Well, that doesn't really make sense. How could you be at a negative time? We don't really need to worry about why it's giving us that negative answer. Just kind of realize that that doesn't make sense. That's the answer we can ignore. There may be some situations where you get two answers that do make sense, both being positive times. This is not one of those cases. Okay, so the only answer we really care to include is that time being 2 seconds. Okay, so at 2 seconds, the rocket would be at 192 feet high. All right, and then that's all of section 6.5.